Welcome to our review on energy and work. So when we're talking about work, what we're actually referring to is the energy that's being transferred by a force. So if we have a look at the little picture at the bottom there, then you can see that we've got someone who's got one dumbbell up in the air and one down at his side. So when we're looking at this, what we actually find is that A, the one up in the air, has had more work done on it because we've transferred more energy by lifting it up than we have with B. So what we actually need to consider when we're thinking about how much work has actually been done is two things. First one is the distance moved, and the second is the size of the force. So when we actually look at a definition, then we can say that 1 joule of work is done when a force of 1 Newton moves an object 1 meter in the direction of the force. Now, one of the things that hopefully you are aware of is that you are going to have to learn a fair number of equations for your physics exam. So this is our first equation that we need to know. So work done, which is measured in joules, is force measured in newtons times the distance measured in meters. Now, I've also given you the shorthand version of writing those, so you could write that as W equals F times S, because we use S for distance in physics just to be a touch confusing. Now, for those of you that really don't like rearranging things using basic maths, then you can go back to using the triangle. So you can set it out in the triangle as I've shown you there, and then whatever they ask you to calculate, just cover that up and it gives you your actual equation. So work done, you cover up work done and it gives you force times distance. If you needed to work out the distance, then it would be work done divided by force. If you're working out the force, it would be work done divided by distance. But do make sure you learn this equation, otherwise you're going to throw away a lot of calculation marks. Just to give you an example of the kind of question you could be asked on the exam, there's one here. So a builder pushed a wheelbarrow a distance of 5 meters across flat ground with a force of 50 newtons. How much work was done by the builder? The first thing I always tell my students to do is to highlight that important information from the question as you read it. Sometimes you'll find that they give you an awful lot more writing than you need, and the last thing you want to do is waste time in an exam having to go back and reread things over and over again. So as you read it, highlight any of those key numbers or key words. Next thing to do is to write down the equation you're going to use, because remember, they're not always going to give these to you on the exam. So if they give you this question, step one after the highlighting is to write down the equation you're going to use. Once you've got your equation written down, then you can substitute in those values. So in this case, the force was 50 newtons, the distance 5 meters, so our actual calculation will be 50 times 5. You are allowed a calculator in all of your science exams, so don't sit there and do it in your head, but you use the calculator. Because what we'll find is when you're in an exam, you can get yourself all flustered and make really silly mistakes. So use the calculator to double check it, even if you think this is the easiest calculation you've ever seen and this is something you do in your head, double check. As soon as you've done that, you should have your answer of 250. Don't forget to include the units of joules at the end if they're not given to you in the question. One thing we do need to bear in mind where we've been talking about objects moving is that we've also got this idea of friction. So when two objects rub together, then we have friction occurring. Two examples here for you of where we'd see this. If you rub your hands together, then your muscles are actually doing work to overcome the friction between your hands. And what we find is that that work that's being done is transferred to the thermal energy store. And you know that because when you rub your hands together, you notice they get warmer. Similar thing happens if we think about a car with brake pads. When you put your foot on the brake, then those brake pads rub against the wheel, causing friction between those two surfaces. That then transfers energy from the kinetic store of that moving vehicle to the thermal store. And what we then find is that the energy is then further transferred from the thermal store of the wheel and the brake pad, etc., to the thermal store of the surroundings. And that means your car is going to come to a stop. Hopefully at the end of this video you can now recall that work is done on an object when a force makes that object move, and that the energy transferred is the work that's done. You should also be able to remember the equation for work done, and you should be able to describe how work done to overcome friction is transferred as energy to the thermal energy stores of the objects and the surroundings.